Hi, this is Pete Singer, editor of Semiconductor Digest, and I'm here at SEMICON West 2021 live in San Francisco, and I'm here talking to Kate Dei Cas with EMD Electronics, and we're talking about materials and customers and sustainability and all kinds of things. So Kate, I understand that you've recently made some big announcements about investments in the U.S. and the semiconductor industry. Could you tell us a little bit about that?
Yeah, we have. And just today, we've announced that we're investing $1 billion in the U.S. to keep up with the growth of our customers and the manufacturing expansions for our customers. We're investing $1 billion in our infrastructure in the U.S. to support plant expansions and new facilities to be able to support the industry and the growth that we expect in the next 5 years.
Okay, that's great. And with the massive expansion going on in the industry today, I imagine you're at the forefront of that, where you see basically the customers wanting new materials and implementing new strategies and new demand.
Yeah, absolutely. In delivery systems and services, we provide the equipment that's used in the subfab for our semiconductor materials business. So the chemicals and the gases that we sell within our company, within EMD Electronics, the equipment that we build within my business unit is what is used to deliver those gases and chemicals. So for us, it's about projects. It's about manufacturing investments, because when new fabs are getting installed, they need new equipment to support those factories. And so for us, our business is all about projects. And so we get visibility to it a lot earlier than the materials side of the business. So it's a nice complement to the materials side of the business, because we get visibility a little bit earlier, and we also have visibility from a different angle than the materials side. So it allows us to really understand what's happening from a project perspective, and we can forecast maybe a little bit better because we have different angles that we can check in on.
Okay, I understand. And there's so many new materials being introduced in the industry today, and obviously a lot of those are being developed by the equipment suppliers. But how do you work with the equipment suppliers to make sure that they understand what materials are available and what kind of byproducts they might create and those kind of issues?
Yeah, I mean, we have a key team that works directly with the OEMs. And so we work directly with them when they're looking at new materials and looking at what's going to be needed 5 years from now. We're engaging with them, and we're engaging with people on our materials team internally so that we have visibility to that, and we can then work on developing a piece of equipment that then is able to support the industry in 5 years when they need bulk delivery to support HVM.
Okay. And one last thing I wanted to ask you about sustainability. That's a big hot topic at the show this year. And so many people are focused now on what can be done that's not being done in terms of recycling and materials, maybe using a little less material or anything. What's your perspective on that?
Yeah, I mean, it's definitely a topic for everyone within the industry, and we're really trying to look at how can we enable better usage of materials through our equipment, through smart data analytics of being able to look at the amount of material that's being used, working on ways to help optimize the equipment, optimize maybe the amount that's left in a cylinder, and then also looking at what we can do to reduce the power consumption of our equipment, looking at ways that we have sensors within our equipment. If there is a leak, we can shut down quickly so that you don't release the chemicals to a scrubber or to the environment.
Okay, thank you, Kate. That was very interesting.
Thank you. Appreciate it.
Hi, this is Pete Singer, and I'm back talking to EMD Electronics, and I'm talking to Jeff Catlin. And Jeff's involved in the EUV side of things, and which is pretty fascinating to see how far EUV has come, and actually now in production. So I'm wondering, though, it sounds like there's still some challenges that have to be overcome. So could you give us your perspective on what's going on in EUV and what needs to still happen?
Perfect. Thanks, Pete. It's fantastic to see you in person, and it's great to be live and at an event. And you're right, EUV is a very exciting time in the industry right now. We're kind of at an inflection point. It's not very often that a new wavelength is introduced. And EUV's been around in the buzz for a long time, and as you said, it's in production today. But a lot of the challenges with making EUV affordable and able to keep up in capacity levels for the ramps that are coming on is really what we're focusing at EMD Electronic Materials right now. And really the key focus for EMD Electronics is to address the shortcomings in photoresist technology. A lot of energy and time has been spent on photoresist technology, but we're hitting a wall, and there's a thing that's called the RLS triangle, which we're trying to optimize for the photoresist, but we're finding that there are technologies that can actually enable us to reduce the dependency on photoresist and focus in other areas.
Mm-hmm. Now, my understanding is that there are sometimes problems with pattern collapse during the spin cycle due to forces going on within these tiny lines. And I wondered if you could explain why that's a problem and what solution you've come up with.
Yeah, pattern collapse has been a major issue in shrink. And really what happens is you have a capillary action in which the material, the liquids that are on the wafer, the surface tension will pull the patterns together, and the patterns will actually collapse on themselves. And so you've printed a very nice image, and all of a sudden that image is destroyed by the patterns collapsing. And so what we have developed as a technology is a way to reduce the surface tension and get the water out from in between those features, so that as the wafer dries, that surface tension doesn't pull down and collapse the features.
All right, well, thank you, Jeff.
Thanks, Pete.